last week wasn't the end of the story with these robot arms. Turns out, in addition to almost losing them to the landfill, the brain boxes got separated and they ended up in a scrapyard. Fortunately, our industrious driver spotted them before they hit the landfill and told us where to find them. The 2 blue boxes face down in the mud. That's what we need. Welcome to the Hawaii Keiki Museum. So the PaleBot MX-150 high-speed palletizing robot was built by Toyo Koken KK. It's a Japanese company. They started building them in 2000. I'm not sure exactly what age these ones are. The PaleBot is controlled by this RC30 robot controller. Each one requires its own control unit. They're 3-phase, and they're very heavy. So what is this white box, you're asking? Well, we don't know exactly. It says System Control Unit on it, and one of the blue boxes had a bunch of wires that were going into it. You can see them dangling here after we cut them. When we look inside, there's a series of relays, but there's also a unit that looks suspiciously like it might be important. Now you might think that pulling them out of the mud with a giant excavator was the hard part of getting these robot controllers. But once we got the truck in the building, we had to figure out how to unload it. So Darren quickly rigged up this chain hoist to one of the steel I-beams over the ceiling. This allowed us to lift them off the truck and unload them into the museum.
Nice for the truck. That's awesome. One-handed.
We were both anxious and excited to get these doors open to see what's inside the brain box. At first, this little lock gave us some trouble. Then we realized when you turn the knob to where it says open, then the door panel will open. So what's inside? Well, what we can see is there's a lot of power supply units. There's some noise filters. Remember that this was built in 2000. I don't know why there's so many. They could be indexers or motor control units. They might be providing feedback for each motor. Down below, you can see here's the motherboard. This is where all of the complex logic is happening. And again, this was built before SpaceX or Tesla. One of the remote controls was damaged, but it looks like this damage is superficial, just the screen. And these weren't touch screens at the time. Fortunately, we do have 2 of them, so one of them is intact. Now you're asking, what was in that other box? The white one. Well, when we opened it up, it sure looks like a lot of relays. Most of it is just power management and distribution. Kind of like the distributor in your car. It was probably used to power all the factory stations, each of the individual bottling units. There is one component in here that is highly suspicious as being important. This Mitsubishi power supply is definitely for industrial use. Here's what the robot arms would have looked like while they were in use. The gripper claw would have been aligning all of the bottles so that they pack nice and tightly into a pallet-sized shape, and then the second unit with the suction would pick up the whole thing and stack each layer of the pallet. Remember, our palletizing robot has the little suction cups, so it could have laid down the cardboard right on top of each layer as it was placing them. Until we can figure out what all these things are, the robots are going to sit in our museum and wait for some interested teens to come help us figure it out. The Hawaii Keiki Museum was honored to host the first robotics teams from 2 nearby high schools, Wea and Kealakehe. They were presenting their progress so far.
16th drop in the middle. Quad Falcon drive train with a 2-seat transmission. Our torque is a 1 to 4 gear ratio and a 1 to about 3 gear ratio.
Cameron is one of our artists in residence at the museum. He's been working on some other projects. It was nice to see him explain how the robot works.
Okay, so we have our arm, chain tensioners running down to this motor and these two at the bottom.
And is that motor got an encoder on it, or?
It will eventually. The encoder's probably going to be over here or on the inside of this. To keep track of the position of this and this separately. And then these ones down here will too. They're geared down. I believe that's 50 to 1, and I think this is just a 10 to 1 here.
What's in your power system there?
So our power system, we run our brain from the Rio. So we have battery here, brain here, radio communications here, and then our power distribution board, our PDB.
Got it, yeah.
Which has our fuses and then runs our power to everything such as our compressor here, our lights, our solenoid block, our motors, everything like that.
So adding the pneumatic was not required. Is that adding weight to your robot?
No, it is, but these add a lot more weight. We have a 125-pound limit, and one of our biggest build constraints, because we live here, we have to take this apart and ship it in checked bags on an airplane.
Yeah, okay.
So having everything
So the
kind of
arm
modular.
itself is what's adding the weight.
Yeah, so the arm, these plates.
not the
I mean,
motors,
these
it's
are
not that,
quarter-inch
okay.
aluminum.
Sure.
Our big ones are our battery, our compressor, our motors, and any big plates like this.
And why do you have a big plate on the bottom? Why not cut
This
that
belly
out
pan
and
here.
save it? Is that specified?
That's 16th inch. We just like to do that because it reinforces our frame rails, and eventually, once we get everything set out and laid out to its permanent place, then we can cheese out the rest of it, and we can make these kind of cuts to trim out all the weight of that for shipping and for competition.
Most of the people have done previous
It's like 125 pounds normally.
Every year there's a good enough.
Yeah, so for our transmissions, we have Quad Falcon, 2 on each side. We have a 2-stage. So we have in here a little pancake piston that's pneumatic, and that shifts a dog back and forth. So then we have our gearing here, right? And as this spins, we can, see if I can't get this in here, right? So we can shift, there we go, and then down to our second one. So that's our torque, and then shift it back up. That needs tightened. To our speed.
So yeah, what's the difference in speed between the two ratios?
It's about a 4 to 1 and a 3 to 1. So one of them, and because it's a Quad Falcon, they're both pretty fast. I want to say 22 feet a second.
Wow.
Pretty fast.
That is pretty quick.
So I think it's like 22 and 15.
It seems like it's sort of a tried and true style.
Yeah, West Coast. So you notice we actually have a West Coast here. It
Okay.
rocks back and forth.
Yep.
Our middle wheels on each side are dropped down
yes.
to 1/16 of an inch.
Nice.
Helps us get over bumps, kind of like a tank, right? You have that front, it just rolls over everything. Yeah, it's kind of a tried and true. It's what we're good at. We do it most years. We'd love to get a build a swerve one of these days, but West Coast beats that in a drag race, so it has its advantage.
Okay.
Mahalo, aloha, shaka.